we just started polynomial chapter number 2, an introduction, and I told to revise all the previous knowledge related to polynomials and graphs. Okay, and I had mentioned some chapter names from 8th and 9th standards. I hope you have revised all the previous knowledge. In the last lesson, I showed this slide. Here we can split the chapter into 3 topics: geometric meaning of the zeros of a polynomial, relationship between zeros and the coefficients of a polynomial, and a division algorithm of a polynomial. So we can divide the polynomial chapter into 3 parts. Okay, so today we'll discuss the first topic, geometric meaning of the zero of a polynomial, but we cannot complete the topic. But so we will discuss only linear polynomials, geometric meaning of the zeros of a linear polynomial. Okay, so that's what our objective of today's lesson: geometric meaning of the zeros of a linear polynomial. Okay, so I give you one question: find the zeros of the linear polynomials below. Okay, so there are 2 polynomials given. They are first degree. So we can say they are linear polynomials, and question is to find the zeros. Find the zeros of these 2 polynomials. So you know the idea, how to find the zeros of a linear polynomial. For a polynomial p of x is equal to ax plus b, that means the polynomial degree is 1, and this is the general form of a linear polynomial. For a linear polynomial, 0 of p of x means k. We can denote the 0 as k. Then p of k should be 0. So p of k is equal to 0. That means ax plus b will become ak plus b is equal to 0. So k should be equal to minus b by a. So this is the relation how to find the zero of a polynomial of degree 1 or linear polynomial. Minus b by a, where ax plus b is the standard form or general form of a linear polynomial. Okay, so comes to this first example. So here this is of the form ax plus b. Here a is equal to 1 and b is equal to 1. This is 1 into x plus 1, right? So a is equal to 1, b is equal to 1. So minus b by a is the 0. So minus b means minus 1 by a is again 1, so that will be minus 1. So 0 of this polynomial p of x is equal to x plus 1 is minus 1. And in the second example, the 0 of 2x minus 4 is, so here a is 2 and b is minus 4. B is minus 4. So 0 of this polynomial will be minus b by a. So b is already minus 4. So minus b will become minus 4. That is simply 4 by a is 2. So 4 by 2 is 2. So minus 1 is the 0 of the first polynomial and 2 is the 0 of the second polynomial. So you know the idea. So this is what we have studied in 9th standard. If every linear polynomial in one variable has a unique 0. So a linear polynomial in one variable cannot have more than 1 zeros. Exactly 1 0 will be there. No less, no more. Yeah, exactly 1 0 will be there for every linear polynomial in one variable. We will discuss only polynomials in one variable. Okay. So here, if p of x is equal to x plus b, the general form, a not equal to 0, a can't be 0, because if a is equal to 0, then this is not a first degree polynomial, not a linear polynomial. Okay. Then its 0 is minus b by a. So this theorem or this idea you can see in your 9th standard textbook. Okay, so now we are going to check the geometric meaning of 0 of a linear polynomial. So 2 questions we discussed here: p of x is equal to x plus 1 and p of x is equal to 2x minus 4. Minus 1 is the 0 of the first polynomial and 2 is the 0 of the second polynomial. So we will draw the graphs of these polynomials. And we will check is there any relation, the zeros of these polynomials in geometry. Okay, so I shall open the graph in whiteboard. First polynomial is p of x is equal to x plus 1. So we want to draw the graph of this equation. So we can take the polynomial as an equation like y is equal to x plus 1. You know how to draw the graphs of linear equations. In 9th standard, you have studied how to draw the graphs of linear equations. Okay, so we will draw here the graph of this equation. So y is equal to x plus 1. How we can draw? First, we want to draw the axis, x-axis and y-axis. We can mark numbers. You know how to mark the numbers in a number line, and in the coordinate axis, how to draw and how to mark numbers. Okay, so we want to find to draw the graph. We want to find out some points on the graph. So for that, we can construct a table. So you can write here x and y is equal to x plus 1. Okay, so we want to get some pairs of numbers to draw the graph. You know how to do that. Okay, so you can give any. I think to draw a graph, you know the linear equations. The graph will be a line. In 9th standard, you have studied for a linear equation. The graph will be a straight line. To draw a straight line, we need at least 2 points. So here we need only to find 2 points. So suppose x is equal to 0. Suppose x is equal to 0, what will be the value of y? Suppose x is equal to 0, what will be the value of y?
1.
Y is equal to x plus 1, right? So if x is equal to 0, so y will be 0 plus 1. Yes, right.
1.
So 0 plus 1 is 1, you are correct. Then next, one more point we need. We can choose any x values, the corresponding y value we have to take. Suppose x is equal to 1. So, we can put some gap. So suppose I take x is equal to 3. What will be y value?
4.
4. Okay. So you got 2 points. If x is equal to 0, y should be 1. So in x-axis, suppose we take 0. The corresponding y value will be 1. 1. So 0, 1 is a point on the graph. 0, 1. So 0, 1 you can mark here. So this point will be on the graph. Okay. And next one, if x is equal to 3, y is equal to 4. If x is equal to 3, y is equal to 4. So this point will be a point on the our graph. Okay, so we got 2 points. So you can join these points to complete the graph. So I take a pen and I join these 2 points, and we will get a straight line. Okay, so the linear equations are called linear because their graphs are lines, straight lines. Okay, so this is the graph for y is equal to x plus 1, a linear equation. And we will check. We have found that the 0 of this polynomial is -1, and there's a relation the -1 and this graph. Okay, so you look at this graph. Where does this graph or this line y is equal to x plus 1 touches the x-axis? It meets at -1, right?
Minus.
Yes. What's the coordinate of this -1? This point, the intersecting point.
-1, 0.
-1, 0. Yes. This you know how to write the coordinates of any point on the plane. So -1, 0 is the coordinates of this intersecting point. Okay. So what we get if you draw the graph of y is equal to x plus 1, the graph, the line for a linear polynomial, the graph will be a straight line. The line intersect at -1, 0, and -1 is the 0 of this polynomial we already found. Okay, so the x coordinate of the point of intersection of x-axis and the line of y is equal to x plus 1 and the 0 of the polynomial are same. Okay, 0 of the polynomial is -1. And for the point of intersection of the graph y is equal to x plus 1 and the x-axis, the x-coordinate is again -1. So they are same. That's the geometrical meaning, the idea, 0 of a linear polynomial. Okay, 0 of a linear polynomial will be the x-coordinate of the intersecting point of x-axis and the graph of the given polynomial. Okay, the next question was p of x is equal to 2x minus 4. Y is equal to 2x minus 4. So you want to get 2 points, so you can choose any x value. So we will find the corresponding y value. Suppose x is equal to 0, what will be the y value here?
-4.
-4. Yes, very good. And if x is equal to 1, what will be the y value?
-2.
-2. Very good. So 0 minus 4, 0 minus 4 and 1 minus 2 are 2 points on the line of y is equal to 2x minus 4. Okay, so we can draw the graph. So 0 minus 4, where will be 0 minus 4? X coordinate is 0, y coordinate is -4, so that will be here. And next point is 1 minus 2. So x coordinate is 1 and y coordinate is -2, so it will be here. So we got 2 points. If you get 2 points, you can draw the line. Okay, so I take pen and I draw the line. So the line will pass through these 2 lines and it will go like this. It will go to infinity. Okay, so this is the line of, this is the graph, y is equal to 2x minus 4. Okay, so here we have seen that 0 of this polynomial is minus b by a, that is 4 by 2, that is equal to 2. We have seen it. Okay, and you look this graph. You look at this now. Where does this graph intersect x-axis? It intersects x-axis at here. Okay, what's the coordinate of this point? What's the coordinate of this point?
2, 0.
2, 0. 2, 0, right? 2, 0. The x coordinate we want to tell first. So 2, 0 is the coordinates of this intersecting point. So for this intersecting point, the x coordinate is 2. That's the 0 of this given polynomial. So that's the geometric idea, geometric meaning of 0 of a linear polynomial. So what you have to do? You draw the line for y is equal to x plus b for the given polynomial, and you find where does that graph intersect the x-axis. You choose the only x coordinate of that intersecting point. That will be the 0. Okay, one more example given in the textbook I will show here. Okay, polynomial is p of x is equal to 2x plus 3. Okay, so using the the idea we have studied in 9th standard, the 0 will be minus b by a, that is minus 3 by 2. This will be the 0. And if you draw the line y is equal to 2x plus 3, okay, the graph for linear equation, so it will comes like this. Okay, if you draw x-axis and y-axis, and if you mark 2 points, then you can draw the line. Okay, so where does this line intersect x-axis? So it intersects x-axis at here. So the coordinates of these intersecting points are minus 3 by 2 comma 0, and the x coordinate is minus 3 by 2. X coordinate is minus 3 by 2. So the x coordinate of the intersecting point and the 0 of the polynomial are same. Okay, so that's the idea of the geometric meaning of 0 of a linear polynomial. Okay, so one thing you have to note, for every linear equation, the graph will be a straight line. That's why the word linear comes. Linear comes from line. Okay, so from here we conclude the idea we got now. So in general, for a linear polynomial x plus b, a not equal to 0. A cannot be 0 for a linear polynomial, right? So the graph y is equal to x plus b is a straight line. We all know that. And which intersect the x-axis at exactly one point, namely minus b by a 0. Minus b by a 0. And here the x coordinate is minus b by a, and that is the 0 of the polynomial. Okay, so today we started the first part, that is geometric meaning of zeros of a polynomial. We didn't discuss different degree polynomials, but only linear polynomials. Okay, so we started with a 9th standard topic, find the zeros of linear polynomials below. For the first one, the 0 is -1, and for the second one, the 0 is 2, right? Okay, so then we moved into the graphs, and we have drawn the graph for these two polynomials. We took the corresponding equation, y is equal to x plus 1 and y is equal to 2x minus 4, and we drew the coordinate axis, and we drew the line, straight line, x plus 1 and 2x minus 4, and we have found that the intersecting point of these graphs and x-axis, you take the intersecting point. For the intersecting point, the x coordinate will be the 0 of the given polynomial. Okay, so we conclude this idea like this: and linear polynomial x plus b is equal to p of x is equal to x plus b, a not equal to 0. The graph y is equal to x plus b is a straight line which intersects x-axis at exactly one point, namely minus b by a 0. Okay, and minus b by a is the x coordinate of the intersecting point, and that is the 0 of the linear polynomial.